special characters, system tasks, and compiler directives. So coming to parameters, Verilog allows constants to be defined in a module by the keyword parameter. So there is a term called parameter which is a keyword in Verilog. So these parameters are used to define constants. For example, if we in our module, let's say this is our module, say with some name and with end module, if we want to use a constant, say suppose we want to assign a value of 2 tick binary 00 to our variable a, which is declared as reg 1 down to 0 a. So if we want to declare a value 2 tick binary 00 to our variable a, so and in many places we want to use this constant 2 tick binary 00. So instead of writing 2 tick binary 00 everywhere, we can use a keyword called parameter and assign it to, like say suppose uh, we can declare a parameter and followed by parameter name. Say suppose we can declare as p1. So p1 is the name of the parameter and we will store 2 tick binary 00 in p1. So p, instead of writing 2 tick binary 00 everywhere, we can use this parameter p1. So we can write here a is equal to p1. So p1 is nothing but, instead of writing the constant 2 tick binary 00, we can declare a parameter and we can use it. And we can also modify this parameter p1. So instead of 2 tick binary 00, we can also modify this value to 2 tick binary 01 also by using parameter overriding techniques. By using parameter overriding techniques. So by using this parameter overriding techniques, we can also modify the value of this parameter. So it will help us for modifying the value also. And another use case of this parameter is, for example, if we have a module. So basically, if this module is parameterized, say we will discuss this concept in our upcoming session. So I will give a brief idea about this. So if we have a module, okay, let's discuss this in upcoming videos only. So like this, we can declare a parameter and we can assign a value, a constant value to our parameter, and we can also modify this parameter by using the concept of parameter overriding. So Verilog allows constants to be defined in a module by the keyword parameter. So if we want to declare any parameter, we will use the keyword parameter. So parameter is a keyword. So we will use this keyword for declaring any parameter, and the parameters cannot be used as variables. Parameter values for each module instance can be overridden individually at the compile time. Here, the important point to remember is parameters cannot be used with variables. A parameter cannot be used with variables. So it should not be a variable. So parameters should be used with the constants only. Here, for example, if reg 1 down to 0 a, we have declared a variable, then we cannot assign parameter a like that. We can only assign a parameter as a constant. Say suppose parameter p1, and we should assign the value of p1 to a constant. Like this, we have to use our parameters, and parameters can be overridden. We have discussed here, right? So this is a concept of parameter overriding, and the parameter overriding occurs at compile time. So parameters can be overridden at the compile time. So this allows the module instances to be customized. This term will be explained in our future sessions. So we will see an example of parameter overriding in the modules. So it will give a better clear idea about that. So for now, remember that parameters can be used with constants. Instead of a constant used everywhere in our module, we can declare a parameter and we can assign that value of the constant to this parameter, and this parameter can be used throughout the module, and this parameter value can be modified using the concept of parameter overriding. And let's see an example here. They have declared a parameter called, so we have declared a parameter called port underscore id, and we have assigned to it a constant phi. So like this we can assign any, like this we can declare any parameters, and we can assign any constants to our parameters, and we can override these parameters. So module definitions may be written in terms of parameters. This concept will be declared in upcoming sessions, and hard coded numbers should be avoided. Generally, in coding, uh, generally we will not use these hard coded numbers. Instead of using numbers, we can use parameters. For example, in the cases like when we are writing codes for memories, so for creating memory, we will be having width and depth. So width will be having some specific number, and depth will be having some specific number, say 4 or 5, like that. So instead of writing 5 or 4, we will declare some parameters at starting only, like parameter width, and we can assign it a value, and we can declare another parameter called depth, and we can assign it a value. So when we assign these parameters at the starting of the module, then we can, instead of changing the width and depth, for example, if we are creating a memory of width is equal to 5 and depth is equal to 4, so and if we want to change this memory, like width is equal to 6 and depth is equal to 3, then if we are not using the parameter, then in the code at individual places we need to change this value from 5 to 6 and 4 to 3. When we use these parameters, overriding these values will be easier. If we use these parameters, we can at one line only we can modify these values from 5 to 6 and 4 to 3. That is the concept of parameter overriding, will be discussed in upcoming sessions. So with the help of these parameters, the coding will become easy. So this is the concept of parameters. So is this clear for everyone? Is there any doubt, specific doubt? So now let's discuss about strings. So strings can be stored in reg. So in our previous sessions also we have declared about strings. So this is the continuation for that. So strings can be stored in the reg. So the width of the register variable must be large enough to hold the string. For example, we have already discussed that a string, each character in a string is of 8 bits. So for say suppose we have Verilog. So this is a string. So each character in this string is of 8 bits. Say if we have a register of 8 bit, this is a is a register of 8 bit, so A can store 8 bits of data. So if we want to store Verilog in this register A, then A is equal to Verilog. If we assign like this, then only 8 bits will be stored in this register A, since A is of 8 bits, and remaining bits will be truncated, and only the last LSB will be stored in this A. So since each character is of 8 bits, so the LSB will be getting stored in A, and if we display A, then we will get the output as G. So instead of taking register A as 8 bits, if we take 56 bits, that is 8 into 7, that is 7 bytes. So reg 55 down to 0 A, and if we assign A is equal to Verilog, then this string will be stored inside our register A, and if we display the A, then we will get output as Verilog. So this is how we store the strings in a register. So this is a process. So this is also a valid interview point. Like if we declare, this is also a good interview point, that what is the output when a register of 8-bit is taken, and if we assign like this, so what is the output, display the output like that, they will ask in the interviews. So the width of the register variables must be large enough to hold the strings. So each character in the string takes up to 8 bits, that is 1 byte. And if the width of the register is greater than the size of the string, then wait a minute. So if the width of the register is greater than the size of the string, then Verilog fills bits to the left to the string with zeros. For example, here if we take reg 15 down to 0 B, so this is our register of 16 bits, and if we want to store B is equal to this is say some string A. So here we have only 8 bits and we are trying to store it into a register of 16 bit. So if we display the B, then we will get first 8 bits, MSB 8 bits filled with zeros followed by our A. So A, the character, the ASCII, this alphabet has an ASCII value that will be displayed in binary here in the remaining 8 bits if we display in binary. So this is what happens when we try to store. If the width of the register is greater than the size of the string, Verilog fills the bits to the left of the string with zeros. So basically zeros will be appended. And if the register width is smaller than the string width, Verilog truncates the leftmost of the strings. It is always safe to declare a string that is slightly wider than necessary. Here the example we have discussed about a 8-bit register, Verilog storing in a 8-bit register. The bits are getting truncated, and only the LSB is stored in the register. So this is also an example discussed here. So is this clear for everyone? Is there any doubt in this topic? Now let's discuss about special characters. So special characters serve a special purpose in displaying strings, such as a new line, tabs, and displaying argument values. So this is similar to C. In C also we will use this special. Wait a minute. Yeah. So coming to special characters, this is similar to C language. So backslash n is used for new line, and backslash t is for tab, and double percentage is for printing percentage, and double slash is for single slash. So these are the special characters used in C. So now let's move with the system tasks and compiler directives. So Verilog provides standard system tasks to do certain routine operations. All system tasks appear in the form of dollar followed by keyword. So if there is a keyword like this, dollar followed by any name, then this is a system task. So operations such as displaying on the screen, monitoring values of nets, stopping and finishing are done by the system task. So system tasks are like dollar display for displaying something, and dollar monitor for monitoring the values, and dollar finish, and we also have dollar stop. So these are the few system tasks. So now excuse me. So now let's display so now discuss about dollar display. So dollar display is basically use it for displaying the information. So displaying information, $display is the main system task for displaying values of the variables or strings or expressions. This is one of the most useful tasks in Verilog. So for displaying any value or any value of the parameter, it is similar to the printf statement in our C. So here in Verilog we have $display task for displaying the statements. We can display using the $display. So if we want to display any string, then we will use double quotes and we can display it. And if we want to display any register value, for example, if we have a register A and if we store a value of 5 in that register, and if we want to display the value of A, then we will use $display. If we want to write any message, we can write value of A is. If we want to display A in decimal, then we will use %d, comma, register name A. So this is how we will display the value of registers, or if we want to display the value of fire also, we can display like this. So this is the procedure of using $display. Here they have taken $display p1, p2, p3, so on, pn, where p1, p2, p3, so on, pn can be quoted strings or variables or expressions. Here this p1 can be any string or variable, or it can be some value. So this is similar to the printf statement in C. So a $display inserts a new line at the end of the string by default, and the $display without any arguments produces a new line. So this is some of the points to be remember. Yeah. So if we declare, let's take a register, say B, and assign it a value of 6. So reg underscore B is equal to 6. So if we want to display the value of 6 in decimal, then we will use %d. Either it can be small d or capital D. Here in the display, the argument is %d, then the value of A will be displayed in decimal, and if it is %b, then it will be displayed in binary. And if we want to display in a string, then if we have a string like say Verilog, then if we want to display, then in the display statement the string is %s. We should use the keyword %s for displaying the string, and for displaying for displaying 6 in hexadecimal, we will use %h. And for displaying, say for suppose we have a string called Verilog and we want to display in ASCII character, then we will use %c. And for displaying hierarchical name, we will use %m. This we will discuss in our upcoming sessions. What is this hierarchical name? And for displaying strength, we will use %v. This strength concept will be also coming in future videos. And %o is used for octal, and %t is used for current time format. So this is how the $display statement. And we have also %e for scientific format, and %f for real number, and %g for displaying real number in scientific or decimal, whichever is shorter. So basically we will use this %d, b, s, h only. Most of the times we will use this formats only. If wanted, if needed, we can refer this formats. So this is about the display task in Verilog. So is there any specific doubt about this concept, or can we move forward?
No, sir.
Okay, thank you. So coming to monitor task. So Verilog provides a mechanism to monitor a signal whenever its value changes. So this facility is provided by $monitor task. So in case of $monitor, as the name suggests, it will keep on monitoring the changes in the variable. Like say suppose dollar monitor, if we use a, if we declare some register a, and if we use dollar monitor a, then this task will keep on monitoring the value of a. If there is any change in the value of a, then this task will display the value of a. There is lot more to discuss about this dollar display and dollar monitor. This is just basics of this display task system tasks. So here dollar monitor p1, p2, p3, where p1, p2, so on pn can be variables, signal names, or quoted strings, and the format is similar to the dollar display task and used in the dollar monitor task. So and the dollar monitor continuously monitors the values of the variables or signals specified in the parameter list and displays all the parameters in the list whenever the value of any one variable or signal changes. We have discussed at this point here. So whenever there is any change in the variable, then this task will display to us. Unlike dollar display, dollar monitor needs to be invoked only once. So if we want to display any variable, say if we have a register C, and if we want to display the value of register C, if we use dollar display, then it will display the value of C. Again, if we want to display using this system task, then again we should use dollar display for displaying the value of C. But whereas dollar monitor can be used only once in the block, so it can be invoked multiple times whenever there is any change in the C. We need to only specify only once, then it will keep on monitoring the value of C. But dollar display should be invoked many times if we want to display using it. So this is the difference between the dollar display and dollar monitor. And if we have $2 monitors in our module, then for suppose if in an initial beginning block, if we have $2 monitors, $2 monitor tasks with some time delay, say 10 time units, we have another monitor task, so the last monitor will be, so the value in the last monitor will be updated. Here we can see only one monitoring list can be active at a time. If there is more than $1 monitor statement in your simulation, the last dollar monitor statement will be active statement. So instead of using $2 monitors, we will prefer only $1 monitor, because if we use $2 monitors, then the last dollar monitor statement will be active statement, and earlier dollar monitor statement will be overridden. We'll see about this dollar display and dollar monitor more about in our upcoming sessions. We will also code and we will see how it is monitoring and how it is displaying the values like that. So this is just an introduction to dollar monitor and dollar display. And there are two tasks are used to switch monitoring on and off usage. If we use dollar monitor on, then dollar monitor will go keep on monitoring the value of the variable or the argument which we have given inside the task. And if you use dollar monitor off, then it will stop its functionality and it will not monitor the variable. So this is about the dollar monitoring or the monitor task in Verilog. Is this clear for everyone? Shall we move forward? Okay. So now stopping and finishing simulation. So the task $stop is providing to stop during a simulation. So the task $stop is provided to stop during a simulation. The $stop task puts the simulation in an interactive mode. The designer can then debug the design from the interactive mode, and the $stop task is used whenever the designer wants to suspend the simulation and examine the values of the signal in the design. So basically this $stop is to stop the simulation and to debug the design. We will see when we are developing a test bench how this $stop is being used in the test bench. And the $finish task terminates the simulation. So these two system functions are also important, and the difference between these two is also very important. So basically $stop is to stop the simulation. It is not finishing the simulation, it is just stopping the simulation, and the debug and the designer can debug the simulation. And $finish is to terminate the simulation. The simulation will terminate when we use $finish. So this is the difference between the $stop and the $finish. Next, coming to compiler directives. So compiler directives are in Verilog. So all the compiler directives are defined by using tick construct. We deal with the two most useful compiler directives. The tick define directive is used to define text macros in Verilog. So this is also similar to hash define construct in C. So for say suppose if we have if we want to use the if we are building a memory of width say suppose 4 and depth is equal to 5, it is also similar to parameter, but here the difference is we are defining this width and depth using the tick define directive. Tick define width is equal to 4 and tick define depth is equal to 3. So this is done outside a module, whereas parameter is used inside a module, whereas this compiler directives tick define is used outside the module. And if we want to use this values inside the module, then we will use tick width like this. We will use it in our module. So these are the compiler directives tick define. So the defined constants or text macros are used inside the Verilog code by preceding them with a backtick. So if we want to use this width or depth in our module, then we will use tick followed by the name. And if we want to use this depth, then we will use this tick followed by depth. So this is how we will use this. We will also discuss how we are declaring this compiler directives in our code. We will code and we will see how this how we are declaring this and how we are using. This is a brief intro about the compiler directives. And the Verilog compiler substitutes the text of the macro wherever it encounters a tick. Say suppose if we define a text macro that defines default word size used as a tick word size in the code, tick define word size 32 for size. He basically he is declaring word size by using tick define word underscore size underscore 32. Sorry, tick define word underscore size is equal to 32. So this 32 will be assigned to word size, and in our module we can use this word size wherever it is needed. So coming to tick include. So the tick include directive allows you to include entire contents of a Verilog source file in another Verilog file during the compilation. For example, if we have two files, say this is file 1. So this tick include is used in our real-time projects also. Let me see how this is used. So this is file 1 and say this is file 2. Here we have some coding, and if we want to use this entire code in our file 2, then we will simply use this system compiler directive tick include this file 1 name, and we will write our file 2 code. So what happens during the compile time, our compiler will come to this step and it will see this tick include file 1 underscore name, and it will go and search for file 1, and this will combine this file 1 and file 2. So instead of writing entire file 1 code in our file 2, we can use just simply tick include file 1 underscore name, and we can use it. So this is how our compiler directives are used. So this is only the intro about this compiler directives. We will discuss by coding how these compiler directives are used and how this $display $monitor are being used. So by coding we can get more idea how these are being used. So this is about today's session. So if you have any particular doubts or queries, you can stay here and ask, or else we can end the session. So thank you for joining today's meeting.